someone reaches out to you, please let us know. What a great shame, right? I want to have the chat open. Hopefully, if anyone messages you again, if anyone messages you something unpleasant, please DM me or Claudia. We're grateful to have Claudia on here, moderating both our online on YouTube and maybe LinkedIn, I'm not sure. But also, yeah, sweet, on YouTube and LinkedIn. People, throw your questions in. I've turned my software engineering in AI workshop that even last week which was bloody quite late for me, 11:30 p.m. on a Wednesday evening here in the UK, through 1:30, where we went through, and I really enjoyed sharing that with all of you. Had a wonderful group, but I will admit that even that, where I tried to keep it bloody tighter, and I still could not get it under 2 hours. I have now tightened up. I've now tightened up the talk and broken it into 3 different talks. This one is on the AI oriented software engineering and broader technology team. Sweet. We'll do another one that dives in more hands-on to neural networks. I say more hands-on, opposite of that, more foundational principles behind neural networks. And we'll do another one in the same way for large language models, although knowing that really we already have that one from James, so I'll see if we actually do that. And we will also do one on, what else? We will do one on, more classic principles of prediction. What is it to talk about uncertainty, prediction, stochastic mechanics? I guess I can't think of a better way of phrasing it. We'll do one on that. This one, though, is AI team. So it starts, as always, with some shilling for Codesmith. Lol, not really. Some well-earned info on Codesmith, not least because we had such an exciting launch last week of our sorry, let me just make sure my windows are all it's not, it's opened a bunch of new windows. That wasn't what I was looking to do. We had a wonderful launch last week of our beta landing page for much of the new augmented curriculum, which is rather exciting. We also had a fireside chat with the phenomenal Brandy Richardson. This is not shilling for Codesmith. This is shilling for life at its best. Brandy was a software engineer post Codesmith at Microsoft. She got up-leveled in the interview process to a mid-level at Microsoft, think equivalent, closer to a senior level at other companies. At the very big tech firms, they, the mid-level is rather advanced. And she did such a great job in her system design interview that she got up-leveled, and she's now moved on to being a technical product program manager at Google. And her advice is just on point, people. So I'd go and look up that interview with Brandy. Here it is. I'll put it in the channel. But people, please throw in the chat. Hopefully the chat is open to all of you. Let me check. It is. So please throw in the chat your questions as we go, as we dive right in now to our workshop that, let me just close my messages, actually. Hold on. What a week it was last week, right? My goodness. Flipping heck. We had England making it through in the Euros at the very, very last minute. Shout out to Jude Bellingham. Extraordinary, right? And we had a debate to end all debates. Wow. So what a time to be alive, people. So here we go. We are going to talk screen share time. Here we go. Throw your questions in the chat, please. I do want to see them, people. If you don't feel comfortable to ask them. Sure, I haven't drunk any. I overheard someone in the gym today say, in your Barry's, say, for every cup of coffee you drink, you should have 3 cups of water. My partner spends much of the day prodding me to try and drink more water. I have lots of coffee, but so I've not drunk any water, so that's not good, is it? All right, here we go. So we won't dwell on the Codesmith stuff for more than another couple of minutes, but if you have a look at our lovely new landing page, this essentially sums up Codesmith. It is a cute octocap, and that's it. Become irreplaceable. We cultivate technologists, intersection of society and tech, able to meet this moment. A lot of what we talk about, people, is the rise, and we'll talk about it here in this workshop for all your careers, the rise of the scale of problems, or sorry, the growing scale of problems that can be tackled once you have AI in the mix. Software as a tool to solve problems, as the place in which much creativity happens, goes from being suitable for some problems to being suitable for a whole bigger pool of problems. That is fascinating. It is wild. And so that's what Codesmith's about, able to meet this moment as things evolve rapidly. And then Codesmith, we, for once, embracing the term bootcamp. Codesmith's not a bootcamp, but it better put it, it is a bootcamp. And yet you'll learn TypeScript, but over half of graduates use Golang, Rust, C++, Python, i.e. quite different languages, let alone the frameworks. That should suggest you become an engineer. We'll talk more about how you can do that beyond Codesmith as well. Students in Codesmith contributed to TensorFlow.js, used by like Alibaba, megacorps in around the world, speak at Google on things like gRPC, latest web protocols. It's a coding bootcamp, and yet the #1 incoming major is computer science. That's interesting. So anyway, that's a fun site to visit. And I think, oh, you can see the latest highlight recent offers, ranging from your classic kind of big tech, Amazon, people going in an apprentice role at Pinterest, ML engineer at TikTok, senior role, a kind of fusion role here, software engineer, legal prompter, healthcare, Abbott, cognitive software engineer. I can't work out what that is, but I think it's a generative AI software engineer again. So fascinating time, exciting time in this field. So let's therefore skip really all of the rest of the Codesmith stuff here, I think. If you want to read more about it, I'll send the slides, but it lays out how the outcomes of Codesmith are achieved. There's that majors thing. It lays out, yeah. And this workshop, in a way, is all about what a modern engineering team looks like. So there's me. For those, oh, please put in the chat, people, where you are in the world, how you heard about the workshop. Thanks, Jim. How you heard about the workshop. Are you off Meetup, off Eventbrite? If you're in the Codesmith journey, pre, post, during, please do say hello. And yeah, please start throwing your questions in. But we are about to begin with part 3 of this workshop. I guess I decided it, you know, the other ones are going to be part 1 and 2. Maybe this should be part 1. Then we'll do part 1. Give it more context, give everyone more context on the future workshops. Okay, we're going to cover macro trends in tech that are causal factors in the new team structures emerging, breakthroughs in tech that are causal factors, and therefore the explosion in new ventures that are also causal factors in the growth of a new type of tech team. We will then we will then go into what are those new teams like. That's here. Some of you have seen this slide before. We'll then talk about what do you need to do. And as I say, I'm going to try and keep this talk to 45 minutes. Flipping heck, I'll do my best. And we'll talk about what do you need to do to grow in those areas. What are the new mental models you need? What are the new pieces of domain knowledge you need? And how should you think about doubling down on the stuff that is actually universal to being a great builder? Okay, diving in here, starting with the macro trends in the market. What is going on in the last couple of years? Well, we've had the rise of what I call mainstream, or like Fortune 500 tech. Actually, nowadays, Fortune 500, or I guess technically, well, it is Fortune 500, is tech firms, right? Dominant, but not universally. There's plenty of non-tech firms in that Fortune 500. There's a rise of mainstream tech for a couple of reasons. What is mainstream tech? It's JP Morgan Chase hiring more software engineers than any other role. It's New York Times hiring more software engineers than any other role. It's John Deere hiring more software engineers than any other role. Take a look at the YouTube video that Wendover did, which is a, decent YouTuber, on the rise of agricultural technology. And John Deere's like 80% of their hires right now being software engineers. John Deere, they make the tractors. Okay, why is that happening? A few things. Well, there's some causal factors in terms of technology, but what's a consequence of, or why is it happening? One is big tech entering. So if you're healthcare, if you're Abbott, you were, or if you're Kaiser Permanente, or if you're CVS, Aetna Insurance, I think it's a big conglomerate, right, in pharmacy benefit management, worth hundreds of billions, right? If you're in those spaces, you previously were like, hey, we can probably get away without being tech first. Firstly, possibilities emerge that you might have the opportunity to solve with technology as technology gets better. We'll come down to the next slide. But equally also, you're threatened by outsiders. And the outsiders are Amazon buying One Medical for $4 billion because it's going, shoot, we need to expand into new domains to continue to satisfy our shareholders. And there ain't many markets that are worth it, like healthcare, like finance. So if we're not doing it, someone else is going to do it. And so for these incumbents, that's the firms who are already in those spaces, they go, shoot, we need to embrace technology. That's one. It creates a new scale of problems, by the way, new scale of challenges. So hopefully we might have some new scale of solutions. Well, you bet we will. Software-defined industries. This is really fascinating. I first read about the 5G telecom. I first read about the 5G in a really obscure journal that told me all about what it does to you. No. I first read about 5G as not primarily a hardware rollout by the big telecoms companies. Actually, 3 or 4 years ago in The Economist, of all places, I went back and looked at the article, and it is, it was seems to prove pretty spot on that the domain in which much of the creativity, problem solving, and IP, and even profit is happening for a bunch of the 5G rollout, that's supposedly putting, I don't know, cables and pylons, I don't know if you use that word in America, but pylons around the country. Sorry, transmission towers. Apparently it's translating it for me on the Google thing. But that is increasingly, and with this rollout, not the main place in which a company like a Dish or a Verizon is doing much of its creative work, giving much of its edge for achieving 5G results, but rather the software layer. And a lot of the telecoms hardware is more off the shelf that is then customized at the software layer. Software engineers. 5G, I meant to say software defined, I meant to add robotics in here as well, sorry. Flipping at robotics, as it booms, 750,000 functional robots within Amazon's warehouses. The vast majority of the work being done is a software simulation layer where you assess how the robot's going to work. It's a software question. Digital first cohorts, that means whole generations, millennial, Gen Z, alpha, where the entire, or at least large percentage of their lives played out in digital realm. That is an extraordinary wealth of data and experience that can be, therefore, instantly a software-oriented solution. You're not digitizing books in the 2000s. The entire, cohort's existence happened in the digital space. And the very, very nature of software. Let's just put this, the very nature of software. It's fungible and it's composable. That is to say, if you're building a bridge, you cannot use, my favorite example, you cannot use the machine that does the concrete pour to also install the steel rebar. Neither of which I know what they are, but I think those are things. You can't use the same tools. You probably can't even use the same engineer. The software layer that simulates that work or automates the hardware implementation, the automation of the machine that is completing those two tasks, can be the same bit of software doing both tasks. The library of code that tests the edge cases of one can be used to test the edge cases of the other. The software engineer can work on both the steel rebar installation software and the concrete pour software. They probably are the same software engineer. It's fungible. You can reuse the code in different places, and composable. You can pick and, well, it can be the same thing. You can pick and you can plug and play bits across vastly complex domains where you would never be able to do the same thing in hard physical things. You can't use the concrete mixer to also lay rebar. You can in software. These are the fundamental macro trends that drive this new era. And you're seeing in the last 500 offers from Codesmith, you're seeing a boom in graduates going into industries previously not software dominated: finance, healthcare, auto, what's it called? Ford just opened its multi-billion-dollar R&D software center in the beautiful old Detroit Central Station, left abandoned for 40 years. There's so much money and worthwhile investment to be done in this space and investment return for years to come. They converted it into an extraordinary software-driven R&D center. Okay, that's macro trends in the market. What about the breakthroughs in technology? All of these macro trends have created a need and desire from organizations to go software first. Well, what are some breakthroughs in technology that have also led to that, focusing particularly on AI? Well, this has been an evolving space, and I spoke to a professor of mine back at university who worked with Jeff Hinton, who is the inventor / discoverer. I don't know how you really consider either, kind of a epistemic question, of backpropagation, a crucial part of neural network performance, or viability of performance. And this professor, Andrew Parker, who worked as a computational neuroscientist in the 80s with Jeff Hinton, who won the Turing Prize, which is the Nobel Prize for computer science, a couple of years ago, describes some of the breakthroughs that happened to me in the 80s in trying to capture language, how people speak in computers, modeling out human language use in computers. Those are early efforts, let alone that transformers, the thing which are the backbone of much of what we work on, have analogous earlier antecedents. I don't know if it's pronounced that way, but yeah. However, these are things that have accelerated in the last few years. Prime models, and different talk on what a model specifically is, but think of it as the tool that does prediction, and that prediction might be the best set of words to respond to an input set of words. In other words, a question, the best answer, the most high probable that it satisfies the user's goal, response of words, that predictor, that model, those are experimental inventions that depend on breakthroughs in underlying technology. We'll come to that here, but also breakthroughs in analytic reasoning. They are discoveries, or at least identifications of opportunities on how to improve those predictions. Wild. Prior models before the last particularly 5-10 years had significant limitations. This VG, this vanishing gradient problem, is a fundamental challenge that when you're trying to train a neural network, the more layers you add, the more chance you can no longer actually get it to improve its performance. New techniques, things like this ResNet, residual neural networks, these are original breakthroughs. There's a paper, deep residual learning for image recognition by, I think they were there at that point at Microsoft. It was an author called Kai-Ming He, who was then at Microsoft, I think. Now, I think, at least recently at Meta, these were groundbreaking papers that improve or make it easier to optimize deep neural networks to recognize images. These are models, predictors to figure out high likelihood what that image is. Is it a cat, a dog, or something else? Do so by things that are analytic breakthroughs. That means they're to do with the nature of the model, not necessarily the computational power behind the model. They are, creative breakthroughs of very, very, I guess, probably profoundly intelligent people, right? Residual neural networks allow a model to skip layers. So if you have a training stage that involves lots and lots of layers, which again, hold for the neural networks hard parts, there are means by which you can have residual functions that capture the difference between a current layer and a skipped layer that allow the model to be easier to optimize. So these are breakthroughs in, I guess, not even technology, knowledge, I guess breakthroughs in knowledge and technology. So breakthroughs in knowledge, these are discoveries. But it all gets to a whole new level with the introduction of, or at least the establishment of transformers. And for processing human language, interpreting human language, it's this paper that's so famous. Wired magazine has a phenomenal long-form profile, albeit not perfectly accurate, but long-form profile on its authors, what they were doing then and where they are now. Because it is the paper behind all the things we know. It's this attention is all you need. I think lead author was Ashish Vaswani. I think that's right, Ashish Vaswani. Maybe someone can correct me in the chat, but Ashish Vaswani, who was then at Google Brain, and this is the paper that introduces transformers using the attention mechanism, which has transformed, the ability of these predictors to make good predictions about the right text to respond to a human, to other language, to other text, or put that better. No, it was not originally for generation per se. So rather the most effective model predictor that understands how human language is used from a large and efficiently can capture the way in which human language, because that's always a question here, is analytic breakthroughs, insights about how to structure a model, a predictor that allows it to be not require 1,000 times more processing power to achieve the same goal. So that is an analytic breakthrough that improves performance and also improves efficiency, which allows it to do more with less, which you might say, well, just have more input, have more computational capacity. Well, these things cost billions potentially for the next round of models to train as it is. That's beyond feasible. So these are the breakthroughs. Diffusion models that also lean on transformers. DALL-E, these models you'll have heard of, particularly around image generation. So alongside improving analytic performance of these models, that's a sort of fancy way, as I say, of saying the insights about how the models are working and clever ways to ensure they do more with less, for example, alongside there being more power. And this is scaling the performance of particularly GPUs. These are the graphical processing units that you'll have heard of from NVIDIA, because it's made NVIDIA a $3 trillion company. Ha ha ha. Oh wow, sorry, just neighbors and the neighbors texting saying things are going on. Sorry. These GPUs that made NVIDIA very rich, which was probably, I'd love to hear someone say, no. This is not just luck. I mean, was obviously Jensen Huang realized in 2016 that it was really worth investing in this area. But is there something deeper, analogous between the tasks that were originally being done with graphical processing units, GPUs, and the tasks being done in neural network training, which is making our predictors do good predictions? Is there something deeper analogous between them? As in, like, is it a coincidence that it worked for both? Or is there something about capturing deeply complex physical systems, linguistic systems, that inevitably was going to require this sort of computational approach. Because what is the computational approach? Well, the reason GPUs are and their performance is a crucial technology factor in the boom in AI is because they are tailor-made. And as I say, is it coincidence? Or is it actually a deeper thing that what we're really doing with data now or computation now is capturing intrinsically complex systems where this would be the only way, and we're moving to that next level of complexity of capturing a digital manifestation, a physical world, and therefore inevitably this was the model, maybe. Anyway, their computational approach focuses on doing lots of relatively small tasks in parallel, unlike a CPU, in parallel, myriad times, hundreds of thousands of times, small tasks in parallel. That allows you to do what a 3D computer game needs, which is to emulate the physical world through calculation of particularly how light traces, path of light particles trace across. We don't see it in our physical space, but in a game, for you to believe or to look like the pillar in front is a 3D rendered real pillar, as important as calculating how to rasterize or render that particular pillar is how the light from the light sources around bounce off that. And that's really, within a computer game, a question of tracing, calculating the bounce of light from the source as individual particles. And sure, extraordinary number of simplifications to achieve that efficiently. So you're not calculating trillions of light particles to generate as accurate an image as possible. But it is nevertheless lots of small calculations having to be done incredibly fast in parallel, not one after another, but which is not the CPU's focus. The CPU's focus is not that heavy, many, many tasks in parallel. It's primarily tasks in succession, one after another, at least as its main model of action. GPUs, many tasks in parallel, including the ability to, primarily the ability to calculate how light bounces around a physical space to capture that 3D rendered environment as realistically as possible. The more you can capture, the more bounces you can capture, the closer it is to the real physical space, right? Simply. It turns out exactly the same parallelizing of lots of tiny tasks is the ideal preparation for training a neural network, where a neural network, and we're not, again, separate talk, a neural network, the nature of it, the work it has to do to learn how language, for example, is related in a collection of all language, the internet, which would be the corpus, the input to a large language model, how language is related will require testing lots of different importances that you give to how particular words are combined up in one sentence, but also in all other sentences on the internet. And you're going to give little increases and tweaks, decreases in importance to the relationship between different words to ultimately end up with a model, a predictor that best captures how language is used. Don't want to overemphasize that relationship between those two words and that bit of the input text too much, because if you do, it might offset how you capture this relationship with two words. You're going to make those tweaks, Googleplexes, a big number, worth of little tweaks. That's lots and lots of tiny calculations that you don't want to do all after another, one after another, but in parallel, identical, at least highly analogous computational structure, computer doing stuff, structure to what you do when you're trying to render a 3D space in a game. Beautiful. Their performance has rapidly increased. The availability of them has not in quite the same way. And so, of course, they are priceless, and NVIDIA is a priceless company. And then there's also a growing community. This was the data science machine learning research group that we've now folded into the full Codesmith program that had so many great workshops, participants over 22 to 23, which was when Alex Zai, who was the lead on that, built out much of our machine learning curriculum at Codesmith. Okay. So big breakthroughs in technology. So what's that look like in terms of companies? Well, a lot of areas. Foundational models, that's the major predictors that are trained on billions of parameters potentially. Often that data requires categorizing beforehand. Look at an image of say, a self-driving car company needs to be able to identify pieces of an image to train to use as the input to those models. Bunch of labeling companies, Scale AI, one that's founded by his name Alexander. Is it Alexander Wang? I think I may be getting that wrong. But who is the latest Valley savant, 27 years old, CEO, $14 billion company, annotating and labeling data, customizing tools to help make your model not the foundational model, but tailored to your company. Synthetic data models need training data inputs to make the predictions better that is not real because you can't find enough real data. So synthetic data is artificially created data. Ton of companies emerging for that. Put your model, your predictor, live on the internet. Ton of companies emerging for that. Hugging Face being a huge one, funded heavily by, I think, both Amazon and Google, potentially. They're all tracking models and understanding how they're working, where they're breaking. Fascinating area. A lot of uncertainty on that front. End-to-end applications that allow you to build out your LLM, let's say, but generative AI or ML applications end-to-end. These don't all do that for sure, but it's in the same sort of region. Yeah, Bedrock's a huge one from Amazon. LangChain, we'll see that come up again, but that's a major tool. There's TensorFlow that some of the Codesmith students contributed to. PyTorch that I think was used in Tesla's autopilot, in Uber's I think it's called Pyro, which are their big end-to-end AI-driven applications. Streamlit, that's a tool that lets you turn your data scripts, including ML experiments or models, into shareable web apps. We're not going to dwell hard on this here, although really every single workshop we do on this should dwell on this. So actually, let me rescind that. But the other workshops on LLMs and neural networks will talk heavily about alignment, safety, compliance. You are using often human labeled data. That means they looked at some pictures and went, that's that and that's that. Or they, in the case of the example I like to give, the automatic refund on DoorDash, they previously had a customer service rep say, yeah, I'll give you the refund. No, I won't give you the refund. That's human labeled data to, in future, automate that decision by a computer based on that human labeled data. Big problems of safety for users, big problems of compliance with any and all requirements. If you're trying to use that sort of thing and you're a company with any degree of compliance requirements requiring, what's it called? What's that? What's it called? I had to do it recently on Google, where you look into the history of something. I don't know. It's got maybe someone remembers the name, where you an investigation, an investigation into the history of an audit log. Yeah, an investigation, an audit log. How are you doing an audit log on a domain that is black box? The black box in an airplane, like an uncertain, hidden thing. Compliance becomes a huge factor. Prompt engineering, tools to potentially enable people to use human language to build stuff. Okay, emerging landscape there. And emerging verticals. These are sort of domains. Maybe you've used some of these things. How exciting to see some of these pharma drug discovery. Anyone and everyone is trying to build their AI-driven. I interviewed for Case Text 10 years ago. Don't know when they suddenly became an AI legal company. Brilliant. We're all AI now. Okay, sweet. So what's it mean in terms of a given team? And so, yeah, these are all different verticals. Very exciting. But let's take a particular team and dissect what goes into it now. Oh, we've got a ton of questions in the chat or comments in the chat. Let's just dive in for a second before we explore what goes into a modern team. Antecedents. Thanks, Jim. I bet you in the UK it's pronounced antecedents. If it isn't, though, how do British people pronounce antecedents? No, definitely antecedent. Thank you, Jim. Great. All right, never mind. Yeah, so we'll talk about what a team structure looks like, how a team evolves, where you fit in. But let's just quickly see if we've got any chit chat in here. Sweet Envy, love it, love it. Welcome, J Fan, what a cool name. Brooklyn, Eli, or Ellie, but perhaps Eli. Nice one. Oh, we know one. An icon of Codesmith. Welcome back. Phil Troutman's best friend. LOD, what a fabulous name. Saeed, lovely name as well. Mian, welcome. We love having you on, Mian, always. I owe you a message. I did read it. I'm sorry for not responding yet. Okay. Good stuff. Let's get back to it. I'm not seeing any questions, though, people. Where are your questions? Maybe I need to change my voice tone to make it more encouraging to questions. Okay, so let's take an example, AI-oriented product. In practice, as we saw earlier there, and once you are, and a lot of the companies that are practically trying to implement a lot of these areas, it's LinkedIn enabling the feature or developing the feature that lets you, I don't know. Good example is they're small, they're little features. They make life, they're definitely incrementally leveling things up, but they're small. Think about when you click a new message to somebody on LinkedIn and it generates, an opening for you, or there's under a LinkedIn post the ability to begin to research that person. Give me the history of this person. Press a button. Okay, so they may be features in bigger companies, but let's take one here where, it's the company because it's a newer company, and so we can get really tight and defined. So we've got lex.page. It's a Google Docs text editor, right, where you can get your writing proofread. So increasingly, this is a feature of a lot of text editors. Apple's brilliantly named Apple Intelligence AI, you never knew this, stood for Apple Intelligence all along. Product has a proofreading tool built in, coming in their new releases in the fall. And Lex.page has that. So you start writing and you have some scrappy text you drafted and you can say, please proofread this, and you'll get back a couple of suggestions of the proofread text. So what's the team that built this product and, in fact, this whole application and company? Well, you've got the data scientist. Their job is to, actually, it's a very experimental job. There's a good reason it's called scientist. They aren't creating a product. They aren't engineering, building a product per se. They are taking source data, which in this case would likely be, there's a couple of ways you could do it. You could have a body of what you consider not very nicely written text and a body of what you consider nicely written text, well-written text, proofread text, and you can develop a model that, where there's no like-for-like comparison between an exact example of messy text and proofread text, you can nevertheless still capture the nature of the language usage in the messy text and the nature of the language use in the proofread text. And from that, make predictions from future messy text, what the proofread version might look like. But likely what the data scientist will have is side-by-side comparisons, a ton of input, scrappy text, and then a proofread version. And they might use one of those infrastructure companies that does synthetic data, that is artificially created data of before and after, or labeled good and bad text from the internet. So they might use one of those. But that then is the basis for them to build their model, and they'll experiment with different models. They'll tweak and experiment with different approaches to a neural network design. They might try a ResNet, as we heard earlier. They might try, a recurrent neural network. They might test out different approaches in order to determine what is my best possible. They might fine-tune the parameters of the model. And their goal is to get their model as reliably as possible, predicting based on their understanding of, they're going to be reading research papers. They're going to be looking at the math in research papers to figure out the best possible model and the best possible parameter adjustments, parameter tunings to make that model as good a prediction as possible, such that when they, on their computer, it ain't on the internet, and it may not work for all edge cases, but they can put some scrappy text in, press proofread, or press go on the model, and generate out a prediction of good proofread text. It's just the beginning. Is it absolutely core? You bet it is, but it's just the beginning. Along comes the ML engineer. Now, the ML engineer's job is to take it from being on the data scientist computer, where they have got it roughly working, to being live on the internet, running fast. It could be super slow on the data science computer, but maybe really, really good, but super, super slow. Making sure it's up to date. Up to date meaning we're going to see that the user can submit their scrappy text, press proofread, and then they can edit it. That's beautiful, not synthetic, but real data. The data scientist is like, oh my goodness, give me some of that. Now I can use that to improve and further train my model. The ML engineer is like, yeah, but let's make sure that training's efficient. That's not going to cost a ton of money. That's the ML engineer's job. The ML engineer is the dream / incredibly challenging job, and it's why it is such an edge to be this, where you have to understand the math. How are you going to make it fast and cheap if you don't understand how it's working? But you also got to understand the computers that you're running it on. How can you efficiently parallelize, put all the little tasks of checking these trillions of different importances you attribute to the word combinations to see which is the best and most predictive combination of importances you attribute to the different word combinations. How can you possibly know how to spread that task out over multiple computers or on the most efficient GPU if you don't understand the computers, how code runs, how tasks happen on a computer? So that's the ML engineer. They've got to understand the math, the analytic, the stats, and how computers run. They make it fast, cheap, up to date, and live on the internet. Software engineers come in here. And I'm talking any person who graduates Codesmith would be working at this point and in the bucket below of software engineers building out the rest of the app. Software engineers come in here where they need to integrate the prediction. So take the scrappy text, messy draft, and the user now presses proofread and gets back maybe a couple of different potential proofread, a couple of different potential edits on the input text. The software engineer here really has to understand, and we'll talk about the domain knowledge you want to grow in and the mental models you want to develop. They have to understand a whole bunch of ML adjacent pieces here to be able to effectively integrate that prediction. They might even be helping the ML engineer deploy, that means put on the internet, where you can access it as a URL, an API endpoint, an address, place on the internet, that model, that predictor. They might be helping the ML engineer doing that, especially in a smaller team. They might be doing it. They certainly might be designing the API, that's the access point for that predictor, so that when the user writes their scrappy text, presses proofread, it sends a message and gets back the proofread text. They certainly are going to be thinking about the data pipeline, which is the flow of data through this application from the data scientist's initial first model that makes a good prediction. The ML engineer makes sure it's fast and cheap and live on the internet. But then the user gets to edit the proofread text, and that becomes new data that improves the model. That's our data pipeline, the flow from the input data that first provides the input to the model so that it can make a good prediction for the user. The ML engineer who puts it on the internet, the user then gets their submission of scrappy text and gets back the proofread text and then edits it. That's new data flows back to improve the model. That's a data pipeline. Well, the software engineer, not the ML engineer, maybe, but hopefully the software engineer can take this, has to think about the pre-processing steps of that data pipeline, which is the user writes stuff, says proofread. Well, what are you sending? What's the format? What's the snippet you're sending? Like, what's the, how do you want to send some of the history of the edits? All that requires you as the data, as the machine, as the software engineer, to understand the nature of the model. You can't just be like, send it, who knows? You got to understand, what is this model doing? What is the nature of an LLM that ensures that it can handle some unstructured data, but not without limit? And then the data you get back, which will be the predicted proofread text, how do you make sure that is also ready for the user? Because who knows how it comes back? And then what about the fact that the user then makes their edits, but they make it for 10 minutes and the text has lost its entire meaning? That's not good data to send back as the snippet to improve the prediction to the data scientist. That's hopeless. So how do you use your understanding of the nature of the model that the data scientist is building and then retraining and improving with that new information from the user's edits? How can you use your understanding of the model and what it looks like to ensure that the snippet you send back of the user's edits is actually useful to the data scientist and can help improve the model and not useless because it's like a complete changed thing? You've got to understand the nature of the model, the nature of model deployment, the nature of data pipelines in order to be the software engineer whose job it is to say, I'm not an ML engineer, but. And by the way, in some cases, from this, you quickly become borderline an ML engineer. Not quite, without perhaps really some serious self-study beyond Codesmith. But we've seen it, grad went to TikTok, who is a pure ML engineer. Now they did a bunch of self-study alongside. A lot of grads do software engineering for a year, then take on some sort of ML masters or data science masters, and then switch into pure ML engineer. But this is a highly valuable space. This is, you look for job titles like software engineer ML platform or software engineer MLT. Highly, highly powerful place to be. And then there's software engineers building the rest of the bloody app. Doesn't matter how cool the prediction bit is and how central it is to the app, and maybe what got them the investment, right? In the end, you got to build the rest of the app. Like, how much of the LinkedIn feature, you see it on LinkedIn because it's just a feature, right? When you can research this person, press the button, I think you can pretty quickly realize the prediction. When you see a post from someone, you can click research this person, whatever it is, learn about this person's career, press a button, it's going to give you some sort of generated response. I think in that case, you can really see the generated response bit is definitely the core cool part of the feature, but it's like 10% of the engineering required to make it go live. And so that's, and their software engineers can use some of these new workflow best practices. Okay, shoot. All right, so let's now talk about what it is to be a great engineer in this sort of team. How do you basically be this bit and continue to be good at this bit? Okay. Well, firstly, core overarching idea is it's about being a modern software engineer. I did a chat with Brian Holt, who is one of the most high achieving software engineers in industry. Go look up Brian. He's worked at every company: LinkedIn, Microsoft, Google, LinkedIn, Microsoft, Netflix, Snowflake, Reddit, like every bloody company and literally implemented at Reddit React for the first time in 2013. Employee number 29, early engineer. So really amazing stuff. He emphasizes what, has always been the case, but is even more important, is this modern engineer whose job it is to convert complex needs of businesses, society into incredibly and increasingly complex technology systems, including AI ML. We at Codesmith, and I think this is validated by Brian and others, think that comes down to these 5 areas: problem solving, technical communication, engineering approach, in this order of importance, non-technical communication, and then domain knowledge. The demand for that person who can do all these things remains strong. as I said, this is my favorite chart. I say this all the time at Codesmith, which is that over half of grads don't use the main language they learned because they became flexible to solve problems with whatever tool was appropriate. So let's dive in to those 5 areas and see how they're changing in these new teams. Okay, so problem solving, technical communication, and non-technical communication. They grow in importance, but they ain't got new stuff in them. They grow in importance because the tools are changing so rapidly. You've got to be ready to pick brand new tools for the task. You can't have, there's no have 5 years experience with LangChain. It's like have 5 months experience with LangChain. And next year it'll be something different. You're moving increasingly, as I've shared before, Codesmith graduate recently got this job, software engineer, legal prompter. They are working, building out a tool that is providing legal advice using LLMs. The job description required that they were a lawyer with a JD, a Juris Doctor, whatever it's called, and had 2 years Python experience in one role. That's wild. The people all around them are not company employees who've done a ton of like software engineering product development with a bunch of software engineers. So your ability to explain to them as different stakeholders, and Brandy talked about this, of course, working at Microsoft and Google, this is crucial already. But it's also now crucial, even more so perhaps in the Thomson Reuters of this world, where the people you're working with ain't built a bunch of product. They were legal advisors, or they were building, documents summarizing legal recommendations. And now they're building products summarizing legal recommendations. So your same with creative industries, it's going to be very, 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 very disruptive. And I think it's good that copyright violations are being pushed back on. But creative industries is going to evolve again. I heard on Daily Show, the host go, let's agree AI doesn't, AI tools don't do creative. I was like, yeah, I mean, I hear, but also we already use a hell of a lot of tools, but it's only going to go more. Health diagnosis, these are all areas where it was not software where the problem solving was happening. Now it is. So all the people around you need to be brought along on that journey. That means technical communication, the ability to get your concept of a complex domain into the head of somebody else, suited to where they're coming from. Are they a UX designer in that context? Are they a patient in a hospital? Understand the error reporting in a way that they can understand. Communicate the error reporting in the way they can understand is ever more vital. And then also, the tools you're using to solve these problems are even more black box, obscure. All the more important, your technical communication to make them meaningful to others is established. And the non-technical communication, which is, I think, arguably just what Brandy described as the empathy-driven engineer. Again, these phrases become trite. The way you make sure they're not trite is doing as Brandy does, which is you stay on the ground. You continue, even as a technical program manager, to code. There's your empathy with the software engineers. You continue to live the experience of the user. When she was building a chatbot for hospitals, you go and you experience the users' trials when they are using the chatbot. So it's a commitment to investing in understanding of their experience, their lived, again, these phrases get used a lot, but experience. Okay, it's even more important, but fundamentally not changing. What about bucket 3, engineering approach and principles? Go to a different talk I have called How to Get Hired as a Software Engineer, and I talk about what is currently in this, but it is things like the principles of state and view in UI. It's the principle of code execution and lexical scoping. It's the principles of encapsulation. It's the principle of how you debug code methodically and don't, have a breakdown, which we totally, sorry, I shouldn't say that, but having had one, I suppose I feel somewhat comfortable to say, but yeah. What are the new approaches and principles? Well, it's some new mental models. In Codesmith, before you get in the program, we want you to have the core mental models of how code runs, which is a core part that gets implemented in front end, back end, engineering. I was going to say infrastructure and tooling as well, but particularly front-end and back-end engineering. We realized, so that's hard parts of Clojure, right? Some of you have been to it. That's hard parts of functional programming. That's hard parts of object-oriented programming. That's hard parts of asynchronous program design. All of that's pre-Codesmith. In the program, all you're doing is implementing that in React, in Node, in Docker. Docker's a weird one to reference, but in programmatic infrastructure, infrastructure you can code for, as opposed to just configure. However, we want you to have the mental models of how those work before the program begins, locked in. People wonder how people get the outcomes of Codesmith, because they got the key bit, bucket 3, before they even got in. It needs to expand slightly. There's some new mental models you need that are sufficiently different. Like, our conviction is that within front and back end, you can take on any new tool, any new language, whatever, with the mental models you got pre-Codesmith. But I would argue that truly understanding modeling, models, predictors, is to expand your mental models. Sorry, too many words, mental model, too many words, model, to be able to do that. And the new mental models are large language mental models, the key pieces of which are attention mechanism, embeddings, pre-training, fine-tuning, maybe not quite as crucial, tokenization, and then neural network mental models, which, as I say, I'm doing a workshop on, and model pipelines or data pipelines. I would strongly recommend, and we're going to have the video up from it, James's, who he developed with a combination of all that material developed by Alex, Gerard, Emily, all the people who helped develop the machine learning curriculum at Codesmith, and then James now carries forward, but lays out the mental models behind particularly LLMs. Go and develop those mental models. Go to the hard parts workshops. They're free. They're pre-Codesmith. That's expanding your mental models. Okay, that's the other area that's got a big evolution. Domain knowledge, of course. There's always, but it's changing so fast. More important is growing your problem solving, learning how to learn, so that as you handle the tool changes, you're ready to take on the new ones. But deploying prediction, making those ability to predict, the predictors, the models, prediction models, which is deploying your, large language model. It is deploying your convolutional neural network model, your thing that has been trained, has been given a ton of previous input to enable it to work on new problems and make predictions, like new questions, and make predictions of good answers. Deploying them onto the internet to make them user ready. What are all the pieces that go into it? Well, there's the model data pipeline. Tools like Airflow is establishing as a key one. There's deployment, and we saw some of these in the other slide, but the big players have big investments in these toolkits. I'll add in Hugging Face here as well, but also Hugging Face in model integration. LangChain is a really interesting one for us as software engineers. It allows you to integrate LLMs particularly into your applications in a very software programmatic workflow style. Infrastructure, that looks a lot like the back-end engineering at Codesmith. It's Docker, Kubernetes, and other tools, but it's getting stuff on the computer off yours onto the internet computers. I like to use silly, overly simplistic words, but yeah, it's building servers. And then it's also building great user experiences. And again, James has some good stuff on this actually in the LLM's hard part. And then, so this is all about getting prediction integrated in your applications. I'm literally at the point where I'm like, full stack engineer is front end, back end, and prediction. And if you want to sound trite, front end, back end, and AI. And then there's the tooling that makes you more efficient as an engineer. Emerging co-pilots, obviously GitHub co-pilots, automated testing tools, there's a bunch of options. Oh, agent tools, Devon. None of the agent tools are really workable yet, but they're going to give you the ability to spend more of your time problem solving and less of your time finding the right config file to make changes in. The problem solving stays with you. The scale of problem solving may go up even. We may even get to a point where we can do natural language problem solving. But shoot, it's all going to be that problem solving at its core. Okay, so that's what a modern engineer looks like if you want to be in this software engineer, able to handle MLOps and building the rest of the bloody app. So it's the big three stay the same, but get more important. The approaches and principles, expand your mental models, and the domain knowledge, some new areas, but these are going to evolve quickly. So next steps for all of you here. Let's just see if there's any other questions. Oh, we got some great questions from Chada here. And are there, what tools does an ML engineer use? Hopefully, Mian, you saw a good list of them there. I'd also look back, as I say, well, a good list of them there. I'll expand that, Mian, for the next talk as well. I almost want to say I'll expand that for the next talk, Mian, but those are some key tools there. Hopefully that did answer the question there. Chada's asking the similar thing. I feel like, Chada, you might have asked this right before I laid out, hopefully. So Chada asks, what are some key things a future software engineer should learn to stand out? Why does AI like ChatGPT produce incorrect or made up information? Let's keep that one to the LLMs talk, Chada, but it, at the very core is remembering that it's prediction. We understand that if I'm making a prediction based on prior data about an election, that there is a 2 in 3 chance of one person winning and a 1 in 3 chance of another person winning. In any given string of code words produced from a large language model, including one that can reason about code, or can predict code, it is in every single key, generate every single token, every single letter or character or word generated. It is saying, it is 98% certain that this is the next word to post to you. It is 90% certain that this is the best next, but there were other options, meaning that the overall prediction is still something of probability. It is still stochastic. It still involves uncertainty. At its very core, they're not reasoning, although it is fascinating, the emergent abilities, flipping heck, and it really makes you start to think about what is us, what are we as speakers and thinkers, maybe more than predictors of the next word to say. I think we have some pretty special consciousness things, but yeah. So hopefully, Charlotte, gives you a sense as to why, but save that for the LLMs talk. But at its core is its prediction, no different to predicting an election. There is a 2 in 3 chance, a 1 in 3 chance. The reality may or may not turn out to be, the case. There's a 96% chance this is the best predicted word, but it is based on prior data, and this is a new scenario. The question you asked, the code you asked to generate. And what if the original information is inaccurate, sorry. Everything built off that could be wrong. How can we prevent that from happening? Well, we saw some of the company's jobs, which is labeling jobs. Scale AI pays PhDs hundreds of thousands of dollars to clean up the input data and or to clean up the predictions, which then feed in essentially corrected. Maybe it's not manually changing the input data, but it is updating the model based on new corrected input data. So, hey, here's the feedback on this prediction. The claim was wrong based on potentially inaccurate input information. As you say, we've seen Gemini, Google's core model, do the fun, predictions based on Reddit troll answers. Like, how do you keep your cheese on your pizza from sliding off? You stick it down with glue. You're not maybe going to change the input data, but you can fine tune the model with the feedback, the human feedback that says that is a bad prediction. And that's for something very intuitive, hopefully. But what about those advanced questions? Well, that's why Scale AI is paying hundreds of thousands of dollars to experts in fields to give feedback on predictions, on answers, and improve the model accordingly. Great question, Chana. Okay. How to tackle with experience requirements while applying for job roles at a fresh grad. Shri, I would just argue, thank you, Chana. I would just argue that, that's a separate talk, and it's called How to Get Hired, and it lays out why they're looking for experience in problem solving. They don't ask you for 2 years experience in problem solving. They ask you for a proxy for that, which is, I guess if you've been doing React for X number of years, you probably have X amount of problem solving. If you can instead show them that you are good at problem solving at the level they're looking for, which they let them judge, that's why Brandy got up leveled in her answers with Microsoft to a mid-level Microsoft engineer requiring, I believe, 3 to 4 years experience on paper. They chose to up level her to that by how she was able to speak to engineering problem solving. Now, a recruiter can't say to you, give me 4 years of engineering problem solving. How the heck do you write that and submit that? So instead, they look for proxies, that is to say a shorthand, which is hopefully if you've done React for 3, 4 years, you've got 3, 4 years of engineering problem solving. You may not. But if you can show you've got ability of that problem solving, that could be 6 months. That could be 10 years and still not really autonomous problem solving. And that comes, by the way, from a great individual contributor, Meta engineer, answer on Hacker News or Reddit, I can't remember which, where they answered the question, what makes a mid-level engineer? Answer, I've seen people with 6 months who have it and 10 years who don't. It's autonomous engineering problem solving. Okay, so in that case, it's just like submit, don't block yourself, Sri. Yeah. And then if you're really worried that they're analyzing and looking at the history, just make sure you're identifying in your prior roles things that were engineering adjacent. Give them that sense of confidence to at least talk to you because you've got some history, even if it was just Python scripting in a prior role, that's all that should be in there. You don't want any stuff that's not engineering. It's just not, well, within reason, you don't really. Okay, next steps for all of you. 1, recognize what makes you special. Double down on actually things that are general. Problem solving and technical communication. On that note, quickly, before we wrap, I do have here in that video from Brian Holt, 3857. Hold on. Brian Holt.
For me, I give the talks factors of what glob it on to what they already know, very much like being a teacher in front of masters, right? What does that mean to you? Like, what does technical communication mean to you? And now, but and different stages, now as a lead model or someone else to get
when someone asks a question, they won't shut up?
Get them whatever into the head of somebody else.
Yeah. I mean, in my undergrad, really cool writing. It was very dry. It was very later or something like that. My master's called The Complete Intro to PI. Here's how to write docs. Here's how to do technical communication. But it's basically just a course in technical communication. It talks a lot about like, here's how to write docs. Here's how to come across with, get your point out, right? Here's how to back those points up. A lot of it's counterintuitive essays and articles you write for companies and for people's attention and necessarily in a sense like that. It's much more hard to wherever I need them to be in the to them, right? And also elicit response back from them, right?
I want to write.
Okay, so that wasn't the clip. Sorry, everybody. The clip I wanted. Sorry, everybody. That was rubbish of me. The clip I wanted is where he says it's all been technical communication. Like the thing that has made him a lead. I asked him what was it made him like a leader, and it was like all technical communication. Sorry, I didn't have the right clip. Software engineering is now. Don't get like bummed by. Obviously, it's been a brutal period, and for many, including Codesmith alumni, but within the industry as a whole. And while Codesmith alumni, as you can go on the website and see the high achievements of just even April, May, amazing achievements for alumni, there's also plenty of challenges, even now, or has been in the market. But recognize a big long-term vision. Software is the space in which most problems will be solved. Software engineering is the core flow and conduit between the input, the need, and the output, the software, the solution. Okay, so you're already special and hold it down and feel good about that. But then build out your mental models and knowledge in these new areas. Go to LLM Hard Parts with James at Codesmith. Codesmith Immersive, fine. But if you look on if you look on that doc, if you look on this doc here, you can see the AI ML curriculum built into the core Codesmith Immersive. So yeah, That's it, people. Thank you so much, everyone. If you, as I say, if you're aspiring into Codesmith, do go to the LLM hard parts. We will start interviewing, if not immediately, but soon on these principles, because it is such a crucial part of the curriculum. Yeah, build your full stack software engineering experience. It's front end now, it's back end, and it's prediction. This ain't blockchain. This ain't, bloody Web3, defederation or whatever, like on the edge. This is core business of modern software engineering. Okay, folk. So thank you, everybody. Shout out for our questions. The next deadline for cohorts it will be presumably in the next few weeks. Thank you, LOD. Thank you, Fernando. Feel free. Oh, that's right. I should send you my LinkedIn so you can ask. Feel free to connect with me on LinkedIn and ask me questions, or at least follow and ask questions. And then on Twitter as well, feel free to ask questions. It was lovely to meet all of you. To all of our streamers on YouTube and all of our streamers on LinkedIn, thank you, thank you, thank you. And good luck for those of you applying to the program, particularly start to prepare. And if you're interested in exploring these areas, start to investigate yourselves some of those tools that I listed. Easiest one to get started with, of course, as a software engineer, will be LangChain. But really, it's a lot of fun to experiment and explore in these areas. Look out for the neural networks mini session. Look out for the LLM hard parts from James. That's the big one. And wonderful to see familiar faces like Jim, Mian, and we also had Chada again. Welcome back. And we also had, I think we had Juan Hart, which is lovely. So there we go, people. Good night. Thank you to Claudia for moderating enormously. And there we go. Cheers, folk. Good night, people.